Okay, in this presentation we're going to look at a Project Euler question. This is question 5 from the set. This is a series of questions of exercises that encourage students to develop their programming skills and their mathematical programming skills. We're using Julia version 1.6.1, as you can tell up here in the top corner, and we are using Jupyter notebooks. So the question is, 2,520 is the smallest number that can be divided by each number from 1 to 10 without any remainder. Okay, so they're all factors essentially. What is the smallest positive number that is evenly divisible by all of the numbers from 1 to 20? Okay, so what we're going to look at here is remainders and stuff like that. Lowest common multiple, greatest common divisor, and so on. Just as a quick remark, what we're going to do here is start off with the greatest common divisor thing. So there's a little bit of an algorithm to that. Now, I'm not really going to get too much into these algorithms, the greatest common divisor algorithm, but it does actually rely on the remainder and an iterative process based on the remainder. So the greatest common divisor is the essentially 15. Okay. Now there's an algorithm. So if we have a divided by b, or a and b, what is the greatest common divisor? So 120. So essentially what we do is divide and get the remainder. So if we divide 120 by 75 and get the remainder, we will get 75. We will get the remainder, and that is 45. Okay. So essentially what we're going to do here is move 75 here. Okay, and then put the new remainder here. Okay, so 75 divided by 45, the remainder of that will be 30, and so on. Okay, so 45 divided by 30, the remainder of that would be 15, and that's it. What would be the next step? Yeah, so there's no remainder there, so that's what the algorithm cuts out. So it's the last one here, essentially. It's the last non-zero here. Okay, I'll just quickly run another example there so you can have a quick look at that. Here, the greatest common divisor between 120 and 78 is 6. Okay, so just run through it there the same way. You can take a screenshot of it or pause the video or something like that, and you will be able to deduce it there. Just as a quick remark, what I'm going to do here is switch the order such that B is greater than A. Okay, so what happens here if we divide 120 by 178? Well, we get 0 remainder 120. Okay, so essentially that just switches the order. So we don't really have to worry about is A greater than B or is B greater than A. So it doesn't really matter because it just resolves itself almost immediately. Okay, so in this case, the greatest common divisor is 2. Okay, so we're going to write a little function that does this. GCD, this is the greatest common divisor function, and essentially it's a while loop. Okay, that when b is not equal to 0 or it's greater than 0, so essentially just carries out the operation I just described there previously. AB is updated by b and the remainder of a divided by b. Okay, that's it. And then it just returns A. So that is just a sort of an expression of the GCD function, the greatest common divisor function, just as I described it there. So we're just going to use that to start off with. Okay. So GCD of 178 and 120 and so on. Let's just switch that around a bit, see if we get something else. 178, 180, and so on. Okay. A and B is 120 and 15. There we go, 15. Okay. Now, what we're going to do here, this is the LCM, the lowest common multiple algorithm. It's very similar. Essentially what we do is divide A times B by the greatest common denominator of A and B. That gives us the lowest common multiple. Okay. Now, I won't get into that algorithm. It takes a little bit of a while to sort of get into these algorithms, and I'm spending a lot of time in them. But if you're interested in mathematics, the GCD and the LCM algorithms are something you probably should get the hang of if you're studying mathematics. So this is the LCM function. It's something very similar to what we have just done above, and it's based essentially, that's why I spent a lot of time on the GCD, because it's actually a key component of the LCM algorithm. Okay, so they go hand in hand with each other. So that's it. So that will return the lowest common multiple for any two numbers of A and B. So good. Now this is where we use the reduce function. Now this is actually where things are getting a little bit more advanced. So the reduce function takes a function and a list of data items and recursively applies the function to the list of items. It performs the function in the first parameter over the first two elements, and then over that result and the third element, and so on. So it's very useful to get the hang of. Now I appreciate it's very high level stuff. So let's just do it for a summation there. The sum of the numbers from 1 to 10 is 55. Okay. Now that's just how we would sort of look at it there. Okay. Now we use plus there and not sum, and there's a reason for that I won't get into. Now, so what we have here is each number is the first pair, okay, of numbers from 1 to 10, okay, then 3, 4, 5, 6, 7, 8, 9, and 10. So it's the first 10 there, okay. So the output of the first pair when we use LCM is 2, okay. The output, when we go to the third element with the output of the first two, we have 6, okay. And then the output of the next, of 6 and 4, where 6 is the output of the first 3 and 4 is just the next in line, we get 12, and so on. So that works the whole way through there. Okay, so what happens is the lowest common multiple gets updated from each phase. 2, 6, 12, 60, and it just stays at 60 when it goes from 5 to 6, okay, and then 7 and 8 and so on. So it just jumps there from 420 to 840 because we already have 2 and 4 there, okay. 2520, and when we apply that, get the lowest common multiple of 2520 and 10, 2520. So that's how it works there. So that's just a reduced statement. Okay, let's do try it out. There we go, 60, 60. That's just confirming what I've done before. So this is the sort of the process that is behind it there. Okay, now obviously I'm taking it in really small steps, but it's worth getting the hang of this stuff and worth practicing with it. Okay, it's not simple stuff, but you will find this very useful on an ongoing basis. So anyway, there we go. That's the function we need. We're going to call it the lowest product, and it's simply the 1 to n. The input of our function there is n. We're going to call this function lowest product. That's just to simply define a function. That's the key operation there that I just described, and then the end statement there. And there we go. Lowest product of 20 is, what is that number? That is 23 million. No, it's 232,792,560. Now, all right.